Okay, I think we can go on.
Okay. All right. Good evening and happy end of the month to everyone. I'm pretty sure for most of us, the end of the month is also quite an interesting period. So today, coincidentally, we are having a lot of people celebrating their birthdays, including those who were born on 29th February. So happy birthday to those people who celebrated, I think, next year. So, and today also was on this day, Linus Pauling, who is my namesake, was born. He won two Nobel Prizes, one in chemistry and then one in peace. So I think it's quite a good day to have lights on. And this evening, I have with me Dr. Jeffrey Ni Ayi, right?
It's actually Jeffrey Niyamari.
Ni
Sure.
Ama Ayi.
Exactly. Sure.
Yes, Jeffrey Ama Ayi, who is a lecturer at the Department of Meteorology
Yeah.
and Climate. And then we also have Dr. Cyril J. John Boateng, who is also a lecturer at the Department of Physics. He's a geophysicist. So someone said you look like a Nigerian billionaire.
Right, is that somebody's comment on Facebook?
No, Dr. Cody, he said I should take the picture looks like a very rich a
Oh,
Nigerian.
really?
Yeah.
Amen. We are waiting for that.
So, Charlie, welcome this evening. This evening we're talking about earthquakes, the weather, and then the economy. These are three things which have been on our radar. But then for a lot of people, they think, okay, scientists, we don't have any thoughts on economy because whenever the economy is being talked about, they're always calling the economists and then those who are into accounting and financial stuff. But then I believe as scientists, we have a very good idea of the economy and how it affects us ordinarily, and then how we think things should be done. But then the earthquakes and then the weather that falls in within our domain, that one we don't share with anyone. No one can come in without the requisite knowledge. So this
Yeah.
is what we are discussing here. So we'll start with the earthquakes. So basically, for earthquakes, it's become quite key because of the fact that we lost Christian Achu, was a Ghanaian footballer in Turkey recently, and I think everyone had a challenge with respect to people started talking. I even saw some kind of information which went around viral, which was talking about induced earthquakes. So probably Dr. Boateng will take us through what earthquakes are, how it works, and then from there we all have some discussions and see the way forward. So, Dr. Boateng, what are
So,
earthquakes?
oh, so basically, earthquakes are just the ground shaking. So we all assume that the ground should always be stable. That's what we kind of live on. The stable part of the earth where our houses and we walk on and everything. So we assume that it's always stable, right? But then sometimes um, the our understanding of the earth is that even the ground we are on, um, it's made up of plates that are also sitting on another layer of the earth. So sometimes they move against each other. So when they slide or they shake, they move a bit away or towards one another, because these are it's like solid objects rubbing against each other or pressing against each other. There's a buildup of energy or tension, and then one day that tension has to escape. It's like when you put two rocks together and you are pushing them against each other. Something has to give. So one day one gives, and then there's a sudden release of energy, just like what happens when you are pushing two rocks against each other. And that sudden release of energy is what we feel on the surface as an earthquake. So of course, if the ground, because the whole ground is shaking, if anything is on this layer, what happens is then you are going to shake. So if it's a building, our whole concept of buildings that is on solid ground. So if the ground that the building is on is shaking, the building will shake. Everything else we have will shake. And then sometimes the plates move a few millimeters, centimeters. In the Turkey earthquake, for instance, we've seen centimeters of movement in some places, or meters even in some places. So that's what happens with an earthquake. So they're basically earthquake are just the ground that we have, what we are living on, moving, shaking, kind of, yes.
Okay. Okay. So, like in the case of, so I think they've been talking about the Richter scale. They talk about 4.2. So,
Yes.
are you sure on that as to what
So,
that and what it means?
that's it's a log scale. So back to some of your mathematics in secondary school. For measuring the magnitude of an earthquake. So we actually have different types. The most common one we use now is the Richter scale. So the higher you go, then the higher the magnitude of the earthquake. In Ghana, the earthquakes we've had have been kind of low, around 4, sometimes less than 4, 2, 3, right? But the one that happened in earthquake, I think, was 7 point something. So that's really high, and it's log scale. So from one range to the other is like times 10. So the magnitude is actually it's growing bigger. It's not the difference between a magnitude 6 and magnitude 7 earthquake is really, really huge, and it's just a way for scientists and for all of us to understand how massive the magnitude of the earthquake is. We want to understand that. So we just created a scale to be able to measure that. Right. Yeah. Will I not? Do you want us to go to the mathematics? I don't think that's necessary.
I'm sure that will be a bit listed.
Yes. So let's just understand that it's a way we measure. It's a scale for measuring how the magnitude of an earthquake. So the shaking, how big it is. Right. So that's it.
That's very true. So, looking at it in terms of Ghanaians, are we at a risk? One, before I then proceed, let me just remind us that some time ago, that was, I think, in was it 2012?
Mm.
There was this viral SMS then. We didn't have WhatsApp. WhatsApp wasn't that popular. And they were like, earthquake was happening all around Ghana. So you had people moving
Yeah.
to go to try and then, let's say, stay and like in Ghana. Okay. So what are we at risk of an earthquake?
So yeah, so Ghana is an interesting thing in the West African sub-region. So Ghana is kind of like an anomaly. The thing is that the West African plate. So I've talked about what plates are the solid ground we are sitting on. The West African region is on a solid craton, like a solid plate. There's no movement. So that should usually be the understanding. Unfortunately for us, just in Ghana, so from somewhere in Accra, Wager, down to the Kiapim range, and then down towards the whole area, that's this fault along that area, right? And that fault, it's as if the southeastern part of Ghana, so from that Kiapim range towards Keta in the corner, is kind of moving away or moving towards. There's some movement along that line, right? And there's another fault in the sea, just off the coast of Ghana. So these two faults now go and meet at around Wager in Ghana. So unfortunately for us, because of that, we've had some earthquakes in Ghana. So recorded, at least oral accounts, go back as far as the 1600s, when there was an earthquake in Axim, yes. And then in the 1700s, 1800s. The worst we've had is in 1939 in Ghana, in Accra. The actual earthquake, I think, was offshore, but it was felt in Accra, and 17 people died, and hundreds of people were injured. And then there was damage to property, government buildings, and all that. So ordinarily, we would have said Ghana should be stable, because I said we are on this stable craton that is not moving, right? But unfortunately, because of that fault in Ghana, and then because Wager is at the junction of those two faults, Ghana is at risk. We've not had huge ones, so that's also something we should be researching on, whether maybe there's a huge one coming, or there will be enough build up of energy to release a huge one. We are not too sure of that yet, but yes, it's possible that Ghana can be at risk because we've had a lot of them. And I think last year we had a bit in Accra. We had one in Accra last year.
Yeah,
2020 there was one. Yeah, so we've had at least 2.5. We've recorded a couple of them in that range, right? We've not recorded a huge one yet. So, but yes, it's possible. Usually, what will happen is most of the earthquakes in the world happen along what we call the rims of fire, around the Pacific Rim, Chile, on the South American side there, and then for the Asian side, Japan around that side, right? Because those zones are what we call subduction zones. It's like one layer of rock is going under one. So
Okay.
those places are really really dangerous. So Ghana should be stable. In Africa, the most dangerous place is like Kenya, where the East African side is moving away from the main African plate.
Oh,
So that
okay.
should be the most dangerous place. So that place, I'm sure you've seen pictures online where you've actually seen actual splits on the ground. Like
Wow.
one part is separating from the other. So maybe in a few thousands of, not even thousands, hundreds of thousands of years, Africa would be divided into two plates, right? So that's it. But West Africa, it's Ghana that has that problem. So that Ekuapim range into Wager, and then in the sea also we have a fault. So that's what we should watch out for.
So are we able to predict earthquakes?
So no, at currently we cannot predict earthquakes. No, what we can do is that you see we can look at the trend of earthquakes and see there's a build-up of frequency. So there's likely that there will be one, or there's a probability that there will be one, and it will be in this range. We can do that, but no one, as of now in the world, can tell you that tomorrow morning at 5 a.m. there will be an earthquake.
Oh, okay. Okay.
None, there's no one can do that right now. Okay, scientists are working because like it's a serious issue. Earthquakes cause a lot of damage. So if somebody can solve that problem, that would really be great. But it's earthquakes are so unpredictable, so because we don't know when that sudden release of energy will come. We don't
Okay.
understand the full mechanics of what is happening under the surface of the ground. So because of that, there's a limitation. But scientists are working on that all the time. Uh,
Okay.
because to get to the point where we can actually predict when an earthquake will occur, but we've not gotten there yet.
Oh, okay. All right. Okay. That's very great. That's very great. So now, maybe this will be the last point. Notice that in Accra and then other parts of Ghana, people are building on hills. Like it's now part of the fashion. Like let's say you talk
Yes.
about Party Hill, you find lots of buildings on hills, Kwabinya. Sometimes I'm like, isn't it dangerous?
so, so for Accra, there's a there's a huge challenge because see there are two things you can do. In Japan, they have the worst earthquakes in some of the very big earthquakes in the world, but they've learned to engineer their buildings so that they can withstand earthquakes. So you can have magnitude 7.6 earthquake in Japan, and the building will still suffer minimal damage because they've
Okay.
learned how to engineer the building so that some of them move with the earthquakes, they shake with the earthquake. Some of them find a way of dissipating the energy that is coming from the ground, so it doesn't affect the building itself. So those are solutions you could have. Our problem, our challenge in Ghana is that we are not doing the engineering, but we are on, especially in Accra. So Accra is something we should look out for because you're talking about Makati Hill. Makati Hill is near that junction I'm talking about, the Wager and the Wager band, the junction of the two faults. So ideally, if we're going to be building there, we should be doing a lot of engineering. We should understand what kind of building should be there. We should be able to say before you build there, you need to get multiple permits. You need to engineer your building to withstand an earthquake, maybe magnitude 4, magnitude 5, or magnitude 6.
Okay.
We should do that, right? But we are in Ghana, so some of the things are not being done. And Ghana, people are actually building everywhere. So one of the things, if you read back to even scientific papers in the 40s, after the 1939 earthquake, the British did a lot of research on earthquakes. And some of the things they decided was not to build high-rise buildings in some parts of Accra. Or if they
Okay.
were going to build, they will need to excavate the top layer because Accra was previously like a bed, a river bed kind of, an
Okay.
old lake kind of. So you need to, and then if you have a lot of that sand sitting there, and there's any shaking, that transmits the energy faster to your buildings. So for most of the buildings, when the British were requesting that if you build something like that, excavate a lot of the topsoil so that you can sit on the bedrock, something
Okay.
like that before you build. Then you can. So a lot of, if you realize, a lot of the colonial buildings in Accra were not very tall. If you realize that they
Yeah.
were not tall at all. If you see
In fact,
Legon,
they wasted a lot of land.
yes, but if you realize, University of Ghana was built after the 1939 earthquake. They made
Yeah.
sure the buildings did not go. And if you, up till now, Legon doesn't build high-rise buildings because that was the policy. Kolebu was built out in 1939. You realize that they don't have a lot of high-rise, so it was a policy because they knew what could happen. Right
Okay.
now, we've ignored all that. Now the question is, if you are going to be building with a lot of engineering done, because engineers can actually do that, build to withstand an earthquake. So if you will do that, then we are safe. But if you are building like anybody goes to buy land because he has money, he sets up, especially on like the McCarthy Hill you are talking about, the multiple risk is now that you are building there, the ground itself is going to shake. Because you are on a hill, it's likely that it will blow. There will be how do you call it? Rock falls, landslides, all sliding down to these buildings. And if you go to anywhere in Ghana where we are building on hills, it's not like we do any proper engineering. We don't cut the rock well. We don't make sure we structure our building so that there's any protection from the landslides and all that. So those are the multiple problems that could occur, right? Something like a people are building on a rock there. So even there, you can already see that rocks. We have rock falls onto the from the Adenta Ebri road. You're always having
Yeah.
rock falls there. Yes. So if we were going to do the engineering, we don't have a problem. But right now in Ghana, with uncontrolled building, permits, you are not even sure if somebody has the right permit. People are building everywhere, uh, and the density, the population density of Accra,
Yeah, it's quite huge.
like we are breeding a monster.
About at the moment about 7 billion. If
7 million.
I
Well,
think
that's the population.
about 7 million because
Then so that's something we should look at. If not, and that range, even some of the earthquakes that have happened affected a range from that Wager area right to Cape Coast. So
wow.
even those new developments around that side, if are they following the right rules? Have we done are we telling them the right thing to do, or people are just building again? Like I said, anybody does whatever they want. If that's what we are going to do, well, then we are breeding a monster.
So that means that it's not really far away from us.
No, no, no. We see that there's something in earthquake risk, that if an earthquake occurs in the Sahara Desert, there's no risk because nobody lives in the middle of the desert, or even
Yeah.
if it's some Bedouins living in a tent. If an earthquake occurs, the tent collapses. You just wake up and put your tent back on. So the risk is not there. But if an earthquake occurs in the middle of Accra, right, where people
Yeah.
are living, so many millions of people are living, right? Even if it's just a little shake, now you are in trouble
Okay.
because now the buildings are of low quality. All these buildings are falling down. We are in trouble. So imagine that in 1939, look at the population of Accra, and 17 people died. 1939. What was the population of Accra? How many people? How many big structures did we have? If even a 1939 earthquake were to repeat now in Ghana, in Accra, what will happen to us? That's a good question we should ask ourselves. With the density and the kind of buildings we have and the quality we've foisted on, because some of our buildings are even collapsing without any earthquake.
Yeah.
Yes. So even if we get the same 1939 earthquake, what will happen in Accra? Now that we have millions of people, not hundreds of thousands of people. That's the question we should be asking ourselves.
Yeah.
Yeah.
Very true. Thanks so much, Doc.
Yeah.
Dr. Aryee,
Yes, Dr. Labik. Sure.
the weather has been changing.
Yeah.
Yeah, and it looks like the last time we had, I don't know whether it was a resurgence of Hamatan, but I think your department, you came out with some information which at least cleared that some form of a resurgence of the Hamatan. Everyone tend to have issues. There we got to know there's supposed to be a high, it was an air quality index. and all those things. Can you just briefly take us through what happened then, and then what maybe next is, and then we know what to do.
All right. Thank you very much. I would probably want to start with first maybe where Dr. Boateng ended. So one of the
Okay.
key things we need to understand is when we take earthquakes, earthquakes are natural occurrences, but then
Okay.
the ramifications or the effects or its impact are a lot. It has lots of impacts, not just on, I mean, the end goal is impact on social economy and then general livelihood, but it also affects a whole lot of factors. And of course, the atmosphere is also not exclusive. It's not excluded. It's also inclusive. So one thing we need to understand is, like he said, we've got a lot of people now living in densely populated areas. You've got a lot of migratory activities, and people are moving more into the, town centers. Take Accra for instance. Now, what happens is, in the case of an earthquake, you have not just the shaking, you might also have some land use changes. All right, because I mean, if there's rigorous, you know, sort of crack, shake, it changes the whole land features. If buildings
Wow.
collapse, all right, you've got a whole land use that's changed, all right. So it might be a residence sort of building. I mean, a place that's resident and then it just goes flat. And most of these building materials, construction materials we are using are in a way, materials that tend to also release greenhouse gases. All right, so
Okay.
if there is a crack, aside the distraction that occurs, there's also extra release of these greenhouse gases. The earth also has a very huge storage of carbon, for instance. There's a huge release of carbon. These carbon releases can be termed more natural, but with the introduction of people building and then trying to engage in other activities and doing that more in areas that are prone to these quakes, once there's this occurrence, it would amplify the for instance, greenhouse release, change the whole localized system. The weather locally might be changed into more regional perspective. We also have some changes, and of course, the atmosphere is not sort of bounded. It's not like, even with countries, we have some boundaries, we have borders. I can say, okay, there's a Ghanaian boundary, but the atmosphere isn't like that. So whatever happens in one area tends to affect a wider range. For instance, when there was this volcanic release in the Mount Pinatubo, for instance, we had a strong release of SO2, that's sulfuric oxide. I mean, I mean, we could see in some areas you had sort of some net cooling, others led to some net warming. And of course, we are talking of greenhouse gases, climate change, global warming, and the rest. So it's necessary that some sort of um, restraint is adhered to. All right, we can't just live luxury alone and then not be concerned about the impacts or the effects of them, because whether it's natural or not, our actions would also either amplify it or not amplify it, and so we have a lot to play in there. And then down to the component of the resurgence of the Hamatan. All right, so I saw a couple of releases going out, and I must be strong to admit that I felt some institutions were probably going outside their jurisdiction. Yeah, because um, as this, when it comes to reporting on air quality, I believe it's one thing reporting on air quality. All right, we can try to trace the sources, but then you don't give an information on the source tracking when you've not done a holistic. You get it, and this is where I think the Meteo Agency could have been involved. That's Ghana Meteorological Agency, the GMET, could have been more involved, because they do a frequent, check on all these synoptic scale features into more micro scale, meso scale features, and how they impact on us. So with what happened, well, there was a circular that said it was because Accra was, just more contaminated and all that. I mean, of course, we know,
Natural
now.
pollution.
Exactly. I mean, it's not as though it was just in Accra. This was something all over the sub region. It was all over a greater part of
Okay.
the sub-Saharan Africa. I mean, West Africa. Um,
Okay.
and of course, we based on so I mean, more credits to the Ghana Meteo Agency, and then also the team on KNUST. That's the forward KNUST team. So due to the frequent forecast that has been issued, they were able to track and see that this was purely because of the increase in the northernmost subtropical high pressure systems. So think of it this way: you have the African continent, and then you've got these subtropical high pressure systems. Now, typically we know that when we have, let's say, any matter or whatever it is, and we have a high pressure zone, we'll definitely get a flow onto the lower pressure ends, all right? And so that's what happens. So you've got all these high pressure sort of systems, subtropical systems. On the northwestern part of Africa, you have the Azores. The northeastern part, we have the Siberian high that's over the Middle East and stretching all the way down. And then it also sort of
So
coincides.
just your flow, eh? But like let's say I remember I watched let's say Met was it GTV News and then the Reverend Steve Nyako is talking of high pressure, low pressure. I'm sometimes tempted to ask what is happening. So could you maybe probably for our audience explain what maybe happens for us to have a high pressure or maybe a low pressure and where that occurs and then
Right, so one of the global phenomena we can think of, I mean, at a quick forehand, is that over the equator, I mean, close to the equator, the equatorial regions, that's latitude zero. Of course, we all know the equator. You've got a direct overhead of the sun almost constantly. Once I start heating up a surface, what I do is I tend to naturally develop a low pressure within that region. Okay, so I mean, when it's relatively colder or cooler, it's got to sort of, it becomes more compact. All right, so think of it as, let's say, having a box, or think of, let's say, water, and then you place water in the fridge. The more it gets cooler or it gets into the ice form, it gets to crystallize. Right now, what you're doing is you're building all the molecules into a smaller, let's say, volume. All right, and then what happens is that, of course, then the pressure tends to increase. All right, because
okay.
based on the relation, pressure, and then all the, Charles law, the Boyle's law, basic chemistry, that P is inversely proportional to the V. So once the volume is decreasing, you are increasing the pressure. All right, and think of it as having 2,000 human beings, all right, in a space that is very big. Now they have that freedom to move. Okay, there's no pressure on them. They are not squeezed together. The moment you put that same 2,000 people in a smaller room, now what you do is you are compressing them, and so they tend to, be more pressured. You have like a bigger force within a small area. All right, and that's exactly what happens. So along the equatorial regions, the direct heating of the sun tends to generate a low pressure. All right, and then what happens is that farther from it into the subtropics, that's, so if I'm talking of the tropics, we're looking about, say, 23 degrees north, 23 degrees south, approximately. These are, sort of interfacial, so not necessarily fixed regions. And now within these regions, you have this high pressure systems, all right? And what they do is, because of the movement, the high pressure systems tend to move towards the low pressure zones, all right? So in the northern part, you have these Azores high pressure system. On the northwestern part, you've got a Siberian. On the eastern part, so that's, like I said, across the Middle East, stretching onto the eastern part of, I mean, the northeastern part of Africa, where Egypt and the rest are. And then when they tend to intensify, then it means what they do is they are blowing winds or air masses over the desert regions. All right, and so what they
Okay.
do is they carry the dust with them and they push them
Okay.
downwards. Now, when that happens, you have what we call the hammerton. So all the regions that they blow over because of the heightened high pressures in the northern parts, they tend to push the dust southwards. All right. Similarly, you've
Okay.
got on the southern part, you have the St. Helena high pressure system. Of course, picked its name from the St. Helena Islands, which is in
Okay.
the southernmost ocean. And then on the southeastern part, we have the Mascarene. Now, these are also high pressure systems. Their net flow is that when they build up, they push the air masses northward, and then these are moving more over, oceanic surfaces. So you take the St. Helena, for instance, it blows over a bigger part of the Atlantic Ocean, that's the South Atlantic, and then it moves further northwards. All right. Now, where we are in terms of, when you take Ghana, for instance, where we are placed northwards of the equator. All right. So what happens is that the direct flow of the I don't know if I would want to go into all the basics, but let me just still give it a try. So you've got these, for instance, I take the Centralina. What it does is it blows the winds northwards, all right, and these are moisture-laden winds, or they carry moisture with them. But then, because of the rotation of the Earth, they are blown sort of more into the northwest because you've got the Earth rotating, sort of along the eastern end. So it's blown more sort of moving northwestwards. These are what we call the southeasterly winds. Now, these sort of deflections are caused by what we call the Coriolis effect. These are apparent motions. Once the Earth is rotating, I mean, that's it. It's like you standing on a rotating object and trying to throw something straight, it will deflect. All right. Then, when it crosses the equator, at the equator, we have no, I mean, Coriolis goes totally zero. In fact, this is actually tested somewhere in, I think, in the eastern part of Africa, I believe Ethiopia or Kenya. So they have this sort of what's the name? It's more like a centrifuge, and then they place it on three ends: one on the equator, one on the northern part of the equator, one on the south end, and then you notice that the one on the north end rotates sort of more anti-clockwise, I believe, and then the one in the south also rotates the other way, and then on then the equator it doesn't change. It doesn't move
Oh,
at all. It
okay.
doesn't rotate. All right. So what happens is when it gets to the equator, because there's no rotation, once it crosses the equator, it's deflected to the
So
right.
another.
Exactly. So the net flow of the southeasterlies then becomes southwesterlies, and so even though they were ideally moving away from
Oh,
the continent, once they cross the equator, they are deflected back onto the continent, and that's what brings what we call the southwest monsoon winds, okay, which are
oh,
moisture
okay.
laden. And so when it's more intensified and it gets over us, that's what produces the moisture, the high humidity, the rainfall, and the rest. So ideally, we were expecting that these two meeting points generate what we call the a convergence zone, and so once the convergence zone goes beyond you, and in West Africa we call that the discontinuity, the ITD. When it goes over you, more northwards over you, then it means you are going to have more rains because the one from the south is what is more dominant over your region. When it comes
Okay.
further southward, then it means the one northward is dominant over you, and so that brings the Hamatan. So start of the year we
Okay.
saw the ITD moving northward, but then somewhere in February it receded again, and that was purely because of the two high pressure systems in the north that pushed it further southward, and so gave us a brief resurgence of the Hamatan. Okay, so it's true. I mean, people are polluting. There are local factors and all that, but the reason for the air quality, of course, I mean, not to sound a bit political, but I don't think Ghana pollutes more than let's say somewhere. I wouldn't want. Let me say China, for instance. Uh, yeah, I think it's
I
it's more ideal.
disagree if you say China.
Yeah, I think no, no, no. I mean, from we all know from the coal, and in fact, let me not even use China alone. Let me say most of the Western worlds here. I think it will be unfair to China. It's just take most of the Western worlds where they are trying to, we want to leverage on, say, okay, industrialization, building more factories, growing quickly, rapidly, and all that. And I mean, most economies are growing faster at rates faster than Ghana, right? And so, I mean, per land mass we are smaller. I mean, let's say our industrialization sort of developmental rate isn't that strong. It's not that much. All right. So I mean, pollution wise, we still emit something. But in fact, if you from a recent study we did, I mean, from the Dasua project in 2015, 2016, on and on, we saw. I mean, some of the researchers from Cote d'Ivoire actually saw that in fact West Africa doesn't even pollute that much, but then we are the ones that bear the brunt the more. Okay, our levels were slightly even below the WHO levels. I mean, recommended levels. It was just on more local scales that some of them exceeded, but as a whole continent, it wasn't. Unless, of course, there's a new finding. So, I
Okay.
mean, to talk of, and of course what we saw was just dust. All right, we can go into trying to understand whether all the pollutants were just dust or we had, say, soot, we had black carbon and all that. That I cannot comment on because of course that's the job of the air quality aspects, and so those were things I was expecting them to communicate more on for us to know, because I mean, dust can be harmful when we inhale them and all that, but to come to a conclusion that it is solely because people are polluting more when, of course, the source has shown clearly that it wasn't just more locally generated, it was something that was over the entire region. That's where it's a bit questionable. And so the brief resurgence we saw, like I said, is just purely because of the intensification of the northernmost high pressure systems. Yeah, but that doesn't mean we shouldn't also take the sort of recommendations that were provided. Yeah.
No, that's great. So now I think one key thing is that so we had a resurgence of the Hamatan and not basically something from air quality. It wasn't basically maybe some kind of a form of pollution in this case.
Okay. So of course, dust is still a pollutant. I mean, when you take the very finer ones, okay. I mean the
Okay, so like maybe man-made pollution in this
yeah.
case.
I mean,
Okay.
so saying it's man-made is where I mean it will be a bit too generic because of course it wasn't purely man-made. I mean, of course, people burn, people do a whole lot of things every time, but the source region for what we saw was purely based on the resurgence of the Hamatan. We had just the um, ITD moving southward and then brought dust all over the, I mean, from the Sahel, the Saharan parts onto our region. All right, it would have been a different case if what we saw was only exclusive for, let's say, Accra, and then it wasn't all over. In fact, in Kumasi, you notice quite similar thing. In the north, it was the same. Places like Chad, we even saw these dust transports from across Chad onto our region. So yeah.
Wow. Okay. So thank you very much on that. But then it looks like challenges when some of these things happen, who to go to is the issue.
Yeah. Yeah, I think it's one of our greatest challenges. In fact, let me even pass in here. So, for instance, I remember there was sort of a tremor, was it last year or a couple of years ago, and then people were going to the Ghana Meteorological Agency. I'm like, no, come on, this is the job of the Geological Survey Unit. Engage them, and it's sometimes it's funny when you expect that the people who are supposed to know, for instance. Let me cut the media a bit of slack, but in some cases you expect that okay, in their reportage they should go to the right people and ask the information, but you don't get that. And I also think it's that's why I also cut them a bit of slack. It's probably because the agencies responsible are not doing much to make themselves aware. All right. Of course, I mean, if you are able to communicate, for instance, what just happened, if some of the agencies responsible could have just put out some, circular, some information, it keeps people more enlightened and they know, okay, so you are responsible for this. And then there's a bit of, confidence building in to that institution, that agency again. All right. And then again, you would also cut the agency some slack because, of course, the chain goes bigger beyond them. I mean,
Yeah. Yeah.
instrumental wise, they're also a bit sometimes handicapped, and it's a whole lot.
Wow. Wow. So looks like we still have a lot of things to do with respect to some of these issues, but these are issues which have trended recently, and for me, I think it's good that we've gotten people who are going to talk about it and then give further explanation to what it is. But now, have our weather pattern changed?
All right.
I don't know, but then I think normally we knew rainy season to begin somewhere. Was it March, April,
Yeah.
or
All right. So,
and
at least we always knew that from early part of March we had the onset of the rainy season, and then this goes on and on till somewhere November, and then like I said, this is purely controlled by it's regulated by the movement of the ITD. That's the boundary between these two masses. All right. So, um, in some cases you might have what we call the false onset. So sometimes you might have some rains early part of the year, sometimes in January, early part of February, and then you know it sort of tricks us. Like okay, it's going to rain, it's already started, but then this is just like a false onset. All right, and then the real season sets in. Now, as to whether they've changed, I would answer the question. Let me say, I'll probably answer that in two parts. I would say yes, because we have a variation in the onsets, and lots of researchers have shown that we have variation in the onset. We also have variations in the cessation, so that affects the growing season. And not just that, the intensities of the rains have also changed, right? And Now you can have, back then you could still have some of those high intensity rains in a short period, but if you look at the extreme events indices, you see some um, amounts of increase in them. Yeah.
Okay. All right. So, anyway, so this issue of climate change,
Yeah.
let's look at it in terms of the context of Ghana. Does Ghana contribute that much to climate change?
Yeah, so every country contributes, you know so whether you contribute marginally or so huge, I mean, you play a role. I mean,
Okay.
that's why the goal is something global. I mean, globally we want to cut down all the risk factors. So is this what is being agreed on is, I mean, people do carbon trading or carbon offsetting, for instance, so that what we do is, okay, well, we know, let's take the industrialized nations. They know, okay, they release more, and so what we do is we can then probably give you some, financial, sort of leverage, and then you use that to, do things that would help, sort of counter the pollution
Okay.
from our end. So, um, I still have a bit of question on that, myself. I still have some doubts on it, because it's a lot. Maybe not for today's discussion. Maybe some other time we can have some deliberation on it. But in terms of what we do, we all contribute. So whether deforestation, bush burning, illegal mining, all the things we are doing, we contribute. So Ghana contributes in a vast way. As to how that compares on the global index, okay, that's not as much as some of the developed countries. Okay, and that's one of the things we are aware of.
Okay. Okay. All right. So, wasn't any concept? Maybe probably you would want to say something on the weather issue.
Oh, yeah. So I was glad when Dr. Aryee sent out I think when they produced the information. I think we're even discussing that because before that there was a lot of, I thought, was misinformation,
Yeah.
that it was pollutants from kind of like in hazardous, um, from industries and Ghana's pollution level. So it was a bit unclear because you could see that it was weather change instead of that. And um, I've I've been in China. In China, that kind of, when pollution is due to like a coal burning in winter, it's crazy. It's not what we saw in Ghana. It's not even up to that level. So it was yes, because there were times you could not see your the next up, how
Exactly.
do you call it, the next block in your yard. You couldn't
Mhm.
see the building
Mhm.
just by, if you get to that level.
Yeah.
So it was
Wow.
surprising. Yeah, I was really glad when they brought out that information, because usually when you try explaining to people that, oh, this, we should wait for the experts, because you don't have any information to share, then it's like you are just blabbing and
Mhm.
yapping off, and trying to defend scientists in a way, right? But the
Yeah.
information, I think, was good. So probably we
Okay.
should be. The other thing is, maybe we should be doing a lot more of that, because the other thing I realize is, this rumor starts, they circulate online, and
Yeah.
we, we scientists also sit aloof. We don't step in.
Exactly.
Government agencies also do not step in. So it continues going around, bloggers, conversations, and then it builds up to the point where it gets to that high level.
Mhm.
By that time, we can't even fight it anymore, because now people
Exactly.
believe the misinformation. So anything
That's
you say doesn't work anymore.
Yep.
You know, it's like the earthquake issue you brought the first time. What happened in 2012? I think it's the same
yeah.
issue. By early morning, by at dawn, everybody was outside,
Yeah.
so you couldn't do anything about it. That we should have taken that opportunity and done a lot of intensive education on
Yeah.
our earthquakes after that. But after that, we all went back to sleep again. We all forgot about it. So I'm sure if it happens, if, let's say, the earthquake in Turkey, because of that, somebody tried to play that prank today, it will still happen in Ghana. The
Exactly.
same
That's
scenario
very
will play
true.
out.
That's very true.
Yes, because we've not done a lot of education. Yes, so
That's
maybe
very true.
that's one of the things we should be doing as scientists. We should spend more time interacting and educating people,
Yeah.
Okay.
just like this, the state agencies as well. Yeah.
Okay. All right. Okay.
For the climate change issue, I'm of the view that the West has been polluting for a long time, so probably they should allow us to also pollute so that we develop. it's a controversial view, but I feel that if it will be unfair to tell countries like Ghana and developing countries, for instance, not take our oil out of the ground and use it to develop. Because Ghana, for instance, right now, one of the reasons we are not paying that much money to generate electricity is because we are using the gas from our oil fields. So if they
Okay.
say we shouldn't develop our gas fields and use for generating electricity, then what happens? We have to go and buy oil from some other country or try and build renewable energy sources, which also cost money. So
Yeah.
the question is, we also need to develop. Now the West has developed on coal for years, and now
And,
they are first world. They can afford to say, "Oh, let's stop."
and that
Even
was
when
cheap.
they say yes, even when they say we should stop, and immediately there's a crisis in Ukraine and they can't get access to gas in Russia. They say, "Okay, now we can go back for now,"
Mhm.
you know. But then for places like Ghana and developing countries where we are, it's actually an existential threat. We need electricity right now. If not, hospitals are not working, people do not have food, factories are not working, which is like the cause of poverty and people trying to cross the Sahara, unemployment, and all those things.
Yeah.
So we should use ours. Let's develop, and then when we also develop, we can think of how to work around the issues
Dr.
of
Watson, so I mean,
because
I
that's what
think
the Asians also did. China did the same strategy. Now China is pumping more money into reforestation than any other part in the world. They've brought back forests bigger than it has ever happened in history.
yeah. So I mean,
But
I think the real
20,
question
30
is,
years ago, you can't tell them to do that.
yeah,
They were not really interested. Yeah. But
yeah,
now, because they have the funds, they can do that.
yes. But the real question is currently. So I mean, it's either you're on any of the sites, you're on either of the sides of the coin, all right? So are you going to fund the, I mean, carbon offsetting or the carbon trade? Are you the one going to pay the money, or you want to be a recipient? So of course, if you're polluting more, it means you are going to be contributing more. All right. So
Yes.
exactly. So that's where
But the
we.
thing is, where I was looking at is that even now, even if we raise our polluting, let's say even if we raise our production capacity in industries and all that by 100, we'll still not get to what the Western world is
Yes,
doing.
and
Oh,
then
yes.
standards
So
are off.
yeah. So we wouldn't get to the Western world, but then there's a WHO threshold. All right, that you
Yes.
wouldn't want to go beyond. In fact, these are agreed not just by individuals. All the various Gs that meet, like the G20, the G8. You come down to the
Oh
IPCC,
yeah.
or the global meetings. I mean, of all these what's the name, protocols that are
Yes.
established. Okay,
Which of the groups is coming next?
you have all the protocols that are coming up and all that, and all these agreements are made. All right, so these are not just individual decisions; these are taken by, I mean, whole countries, or let's say country representatives. So it's one of two
Oh yeah.
things. I think we can develop. I think we can find.
Mhm.
We should be also very creative and find some alternatives. I believe if you still want to, I mean, eat your cake and have it, then it means you have to find alternative ways of creating. And this is where I believe, all these ideas of, organizing, say, hackathons, building ideas, all these sort of
Mhm. Mhm.
incubator hubs and all that can be used to churn out some of these projects in more prototype, build them, find out alternative ways we can do things. All right. So, for instance, you take polythene bags. In Ghana, for instance, you can't buy anything without polythene bags. You go buy, say, bread, you are given a polythene bag. You even go buy a polythene bag
Yeah.
in park, you are given a polythene bag.
Yeah. Yeah.
You get it. And I mean, I believe other countries are, sort of going beyond that. You take Kenya, you take Rwanda, they are finding ways
Yeah.
to, you get it. I mean, recently I was watching a video where somebody was just trying to see the number of polythene bags we use, and if it's not the black one, then it's the plain one, either for your banku, for
Yeah.
your clear, for your, I mean, so you ask yourself, can we ever do without it? You get it.
That's very
So i
Yeah.
believe i
Yeah.
believe we can find alternative ways. I mean, if you want to go way globally industrialized and then also compete with the world, we can still do that. But I believe
Sure. Sure.
alternatives can be churned out and then sort of given some strength. All right, and then we leverage on those
Yeah.
ones to grow. Yes, I mean, that's it.
So
I
I
still
agree
have
with
my.
you on those points. The alternatives for those things is not an option because fine, we are even polluting our own rivers and all that.
that's
Usually,
true.
where the debate is like in terms of the big ticket items like
Exactly.
stop producing, because now one of the requirements is that let's stop producing gas. Let's not even look for oil and gas in the ground. Let's leave it there, right? But
Yeah.
yes, let's leave it there.
Yeah.
Those ones I think are non-negotiable, because at least the West has shown us that even they cannot keep to their own rates. They don't want to. They want to still keep polluting at those levels, but then tell the rest of us that, oh, you haven't gotten there yet, so don't even get there.
So,
Which for me is a bit hypocritical, because then
down.
I know we are the ones affected, but it's some of these things, because the world hasn't really changed in terms of the model of development. You can't play outside. Like one of the things I would say, and I agree with a lot of the nuclear physicists, for instance, let's have a nuclear power plant. A nuclear power plant will be one of the best ways to solve this problem. You can produce a lot of electricity without actually polluting as much. But again, that will also come with restrictions again from that side. That you have to observe this, you have to observe this rule. So for me, it's a multifaceted issue, and especially for the big ticket items like oil and gas and all those things, they should allow us to get our gas out of the ground, produce as much electricity, let Ghana have enough electricity so that we can have more factories. Then we can think of how to solve the
Yes.
problem. Yes.
Dr. Barton, let me just come in a bit. I mean, don't you think sometimes the solutions we are looking at, okay,
Uh,
we are looking at the very far-fetched solutions when even you look at, you take for instance, so for instance, you take what's available to us. I mean,
yeah.
solar energy, you take wind,
Mm.
take I mean all the renewable sources we can think of, and we've not even harnessed them fully. And then
Oh
don't
yeah.
you
Oh,
think?
I
I
agree.
mean,
See,
yes.
you see, I agree with you on all that, but my point is that you see, this is where again it comes in. See, we need renewable. Now, renewable, the cycle of development for every country in the world has been they use dirty coal, get into probably oil and gas. But you see, you need to generate enough, how do you call it, resources, then to be able to invest in renewables. I don't think any country has jumped into renewables without the funds. And that's where, for me, it comes in. Because I've not seen any